All right. Okay. Hello to everyone, and welcome to this third session of our three-parter webinars. Today's session is centered around fuels and technology, and we are quite lucky today as we have a diverse audience, and also we have an international lineup of presenters today. Let me share my screen. Hopefully you can see it. Let me know if you don't. So like I said, this is a three-parter. We already have had a webinar on the 10th of April, which was focused on cybersecurity and threats. Then we had one on the 24th of April, which was focused on sustainability and innovation. And then also we have today's, which is fuels and technology. Let me know if you cannot my screen in case. So this webinar is part of the Maritime Talent Program, which is a European initiative designed to equip maritime professionals with green and digital skills, which are essential for the industry's sustainable transformation. And the program is part of EU's Horizon Europe Research and Innovation Program. And you can find more information on the program overall on our website, our node, and also on our Facebook page. You can find it here. Furthermore, you can find opportunities for networking through our extended network of partners and collaborators, not just in relation to the consortium of this program, but also through our accelerator. You can see here a few of them. And like I said, today's webinar is part of a three-part webinar series. We are at the fuels and technology one, which is the last one. And at this point, I would like to present today's agenda. So we have Robert Kunzmann with us today from AC Biode. We have Elsa Nicole from Falco, and also a stakeholder presentation from Ivaila Petkova from the Marine and Anti-Pollution Enterprise in Bulgaria. And then we are going to end our session with Q&A. At this stage, I would like to just stop sharing my screen and call for Robert to share his. And while he's doing so, just a few words. Robert Kunzmann from AC Biode today will explain how they explore with the rest of the team of AC Biode the field of fuel technology and environmental sustainability through their solutions. So Robert, if you would like to share your screen, the floor is yours.
Thank you very much. Let me just share my screen.
Stop sharing mine, so it would be easy now from your end.
All right, great. Can you see my screen?
In a moment, I think. Yes, we do now.
Perfect. Well, thank you everyone for joining. I see quite a few people here today. we already talked about legislation before, we talked about innovation. Today, I want to talk about fuels, but also at the same time, um, the recycling. And how are these two connected? Firstly, we're starting off with the real problem and why we are all here. There are a few problems in the maritime sector, and one that is very important to myself personally, but also I believe to everyone's health, is the microplastics. And microplastics is a very complex topic, and it's actually not necessarily only from the maritime, but a lot of these plastics come from um, land, from through rivers, um, and more make their way in our food supply chain as well. We see here, for example, just an overview, some things you might already know, some things you might not know, that a lot of it you think is this mismanaged plastic. You have your plastic bag and it gets caught by the wind, but there's also, you see a significant amount here from fishing nets, um, and also in the pie chart at the bottom, you see marine coatings. Um, and all of these make their way into the oceans, and these are ocean plastics. Who are we? AC Biode founded originally, so we met at the University of Cambridge when we were doing different startups, but then united over this vision of eliminating waste going to landfill and incineration. Right? And we founded a company in Luxembourg shortly after, and after that we started with different types of plastic recycling. I'm going to talk you through that today. But first, let's look at ocean plastics in particular. When this is now from when we look at plastics, we find them in the oceans and we see what is floating around. This is what we see. These are the types of plastics, and it's different from microplastics because these can still be bigger. This might still be, you might be able to catch this or gather this. Of course, the bottles is what we all think about, the bottles floating in the ocean. Because PET is only a small part of this. See a lot of polyethylene, of course, your shopping bags. And polystyrene floats extremely well and folds apart very easily. It's very toxic as well. So that's a major concern. And then we have the rest of the category, including PVC, which is very difficult to recycle itself and is also very toxic because of the chlorine and a lot of the additives. So there are many different plastics here today. And I'm happy for you anytime if you have a question, just ask a question. Our background, of course, is in the plastics, so I'm happy to talk about any of these more if you're interested. But really, let's dive into recycling. So this is not just in the oceans, but in general, plastics. If you think about the whole world, less than 10% of plastics are being recycled right now. Most of it goes to landfill or incineration, and a lot of it, of course, is lost and ends up in the oceans. So when we want to increase the recycling, we currently just think of mechanical recycling, which is very good, for example, for your bottles that can be mechanically recycled. But most of your plastic is some kind of multi-layered plastic where you have films stuck together or different materials, and that cannot be mechanically recycled, which is why pyrolysis was invented, where we break down plastics at high temperatures back into oil, which can then be used to make plastics or anything else. However, because of the high temperature and or pressure, the machines we need for this, the process we need, the energy, it's so expensive that it's barely taking off because it's much cheaper to make new plastics, it's much cheaper to burn plastics. But what if there was a way to recycle at lower temperatures these mixed plastics? And lucky for us, there is a way, it's called chemolysis. So chemolysis is a general term for chemical recycling. at lower temperatures. And we are presenting you today the way that we believe is the most promising way of doing this, because it has the lowest temperatures and can do almost any plastic. And this way is called a Plastilist. Plastilist is our AC Biode product that we develop in-house. And we have done almost any kind of waste. We've done the most difficult to recycle plastics. And the way we do that usually is that someone like you comes to us and says, hey, we have this waste and we cannot recycle it. Can you please take the sample and do a test? And we've done tests with over 30 different global brands and companies now. And it's mainly plastics, of course, because organic waste, people don't see like it's a big problem. In many cases, it's not, because, of course, if it ends up in the oceans, it just breaks down. If it ends up in nature as well, mostly it's composted. But still, we have a lot of organic waste, and not all of it can be biologically degraded very quickly. And most of it is mixed with plastic waste. So this is the problem with plastic waste, is if you think of the supermarket at the end of the day, they throw everything away, mixed that plastic waste still in the pack with the food waste. And that currently is very difficult to recycle. And we don't want that to end up in nature or in landfill. The way we do that is, imagine in your kitchen, you have a pressure cooker where you're cooking and the lid is held firmly, and you increase the temperature to 200 degrees Celsius. So these are not crazy conditions. This is normal conditions. You could do this in your kitchen if you have our catalyst. So that's the only thing we can't share today, is what catalyst we're using. So that's our IP, and that's where our patents are going. We break this down into, of course, back into monomers. Monomers are the building blocks to make polymers again. And we're also getting a lot of other chemicals that currently are only made from oil and gas, and we are producing them from waste, and in many cases organic waste. So the carbon footprint is insanely lower. And even if it's plastics, when you make it from all plastic, it's maybe 90% lower than fossil fuels. But if you make from organic waste, it's almost no CO2 emissions from this. So this is revolutionizing the whole chemical industry. And besides these solids and these liquids, we get a lot of gases. And that's what I want to talk about here today, mainly gases and fuels for the maritime sector. So the first, and going back to this one, we had PE, polyethylene, being the largest proportion of waste we find in the oceans. So I want to start with that and then go into PET and the others. But this was our first patent. We're breaking this down back into propylene, very useful gas in the chemical industry. If you'd like to read our patent, please scan the QR code here with your phone. Or, of course, if you get the slides later, you can also click on the link and we'll lead you straight to that. And polyethylene is not easy to recycle. Not many companies have done this, but polyethylene triethylene, PET, a lot of companies has done this back into the monomers, but we are the first in the world to break this down further into methanol, and only at 200 degrees Celsius. So this is temperatures like you could do this with solar panels on an isolated island in the ocean, because you don't need a lot of energy for this. You can break this down. We can make this methanol locally. And methanol is a great shipping fuel. It's something I want to have a look at today. A lot of you will have already heard of methanol. For the chemical companies, what it means compared to usually, as you see here, we make TPA and EG. Ethylene glycol is one building block, is great, but it's not that valuable. So we see methanol, actually the market size is larger and is also growing quickly compared to ethylene glycol. And then when we're doing this, it's almost like water. It's much easier to handle than very thick ethylene glycol. So it's much easier to build that plant, that recycling plant, at lower costs and easier throughput. Then the temperature of methanol to bring it to boiling point is much lower than of other products. That means it's so easy to separate. Once we make the recycling output, we can boil this at 60 something degrees. Very easy to separate methanol and have very pure methanol we can use in the chemical industry or as a fuel, of course. Lastly, if you see any other companies who might recycle plastics, we only use water as a solvent. It's always something you want to have a look at. They're claiming low energy consumption, yes, but usually they're using very aggressive chemicals to break down those plastics. So we only use water, which is very available and easy to clean and reuse. Methanol increasingly used as a shipping fuel. And this is actually, I put this on today, just in the news, new ships with now dual fuel, right? So you might have heard of other shipping fuels, especially ammonia is getting a lot of traction because it doesn't emit CO2. Actually, I have a graph for this here. So ammonia, hydrogen, they don't produce CO2 when you burn them. So that's great. Of course, we have to look at the whole value chain of making this. So if you use a lot of energy to produce this, or releasing a lot of CO2 in the production process, ammonia and hydrogen can still have a significant carbon footprint, even higher than that of other fuels. But in the consumption when you burn it, it doesn't produce CO2. Hydrogen and ammonia. Hydrogen, very difficult to store. You need to use high pressure vessels, and it is not easy to transport as well, so not that suitable for shipping industry, whereas ammonia is much easier. And this is why, of course, we also have DME as more of a niche application, but today I wanted to just say ammonia, methanol, why would you even consider methanol? And that is because you can just modify existing engines. And that's what we see in these headlines from today's news, that more and more ships are now, and this is to transition to a low carbon shipping industry, and not just shipping as we see here. These are, what are these tug ships that we're now seeing more and more being used for methanol. And that is great because it is incredibly difficult to build a new fleet based on a new fuel. It's a big financial commitment to we don't know in the future if this fuel will be available everywhere and at what cost as well. So having this ability to have these dual fueled ships, or where we are transitioning slowly into more sustainable fuels, this is really the role of methanol here, is to enable us to have a smooth transition into low carbon fuels. And then ammonia, of course, has nitrogen, and that leads where we see no CO2 emissions because there's no carbon in ammonia. We do see much higher NOx, so these are nitrogen-based, very bad emissions, and that we don't see with methanol. So that's a great advantage there. And of course, you also have to follow those emission regulations for NOx, not just for CO2. And finally, a point of the storage, that methanol, we can store that in just a plastic container. It's not so toxic. It doesn't require high pressure or low temperatures to be liquid. So it's very easy to store and to handle as well. So for your staff or for the fuel, when you fuel your ship. And then importantly, when we're talking about the storage, the energy density. So with the same amount of volume, you can here have 35% more energy. So the ship can go with the same size tank with ammonia, with methanol can go 35% further than it can. So that's significantly higher energy density with methanol. And we are very interested in this field, so please get in touch with us if you're interested in methanol. And we're specifically looking for partners. They're saying, oh, we want methanol, we want to have a 10-year uptake contract because we need this long-term vision to build this production facility. And of course, we're the first ones to do this from waste, methanol from waste, AC Biode. But in general, Gregory is a great person to speak to in terms of methanol, as CEO of the Methanol Institute. So please, here's his LinkedIn. Please get in touch with him. In general terms, if you're interested in methanol or conferences related to methanol. Back to recycling. So why would you use plasterless recycling? And that is when there are already big technologies out there where you can make syngas from waste. And syngas, we're going to look at in a bit, is like a raw material to make all these sustainable fuels. We can already make that at gasification, and that has been around for many years. But the high temperatures, we're talking sometimes over 1,000 degrees Celsius, that's way too expensive for anyone to make sense of this. Even if you use biofuels, the carbon emissions associated with that, they're also CO2 released in the process, is way too high for companies to really scale this up. And one little bonus on the side, because we use water as a solvent, you don't need to dry the waste. And that's especially interesting for maritime waste when you're taking out the, let's say, the fishing nets, or you have even fishery waste that has a lot of water in it. We don't need to dry that with our technology. Plastless operates on water, and we can have up to 90% water content. So perfect for example, sludge wastewater treatment as well. And no CO2 produced in the chemical process. So we can make different gases, like hydrogen. We can make methane and carbon monoxide as well, if that's of interest. And that is similar to, you might have heard of organic methods like anaerobic digestion, where we make fertilizer, we make biogas, methane, but still CO2 emissions are often put under the carpet because we don't want to really look at this, because it's great and we need more of it, but at the same time it requires a lot of energy. It's a biological process, so if the temperatures, for example, go up and down, the bacteria might die, and the whole process needs to be reset. It's very expensive and it takes a lot of time. Where with the smaller process here, plastless, we can do this in only 2 hours and also process a lot of the things that the biological methods cannot. They're very good at one specific waste if you only have one type of waste, but as soon as you have some plastic in there or some other decontamination, then biological methods usually struggle, and plastless is the way to go. From our side, we have this year, 2025, we're building our first demo plant. So this is the largest scale plant with one of the large energy companies, the largest one in Southeast Asia, actually. And we're building this demo plant, and then based on that, we want to raise a Series A next year. So if you're an investor, please be in touch for next year. In general, we are still looking for joint ventures, or I said partners, to produce fuels, but also to build these facilities together, because we are more a chemical than an engineering company. We really focus on the chemistry. So happy to work with you if you're an engineering company. And then, yeah, we're working with a lot of companies around the world. What I wanted to mention is the recent pilots with very difficult to recycle waste. So this could be maritime. In this case, it's automotive companies that are saying, hey, this at the end of life, all this waste is just burned, because there is no other way of dealing with this. And actually, maritime has a lot of waste like this that currently there is no recycling method for it, so we just burn it. And actually, with another company, not on the slide, we just started with glass fiber and carbon fiber reinforced epoxy. So this could be what lightweight vessels are made of. So these epoxy resins, currently can only be burned, but with our method, we can chemically recycle this. So on the waste side, we want to work with you, but also on the fuel side. So here we are making also what I haven't mentioned yet, charcoal. And that is very interesting because it's basically carbon. We don't release carbon that doesn't go into the atmosphere, but we can store the carbon very effectively. And we have now a contract with one of the largest waste companies in the world to turn plastics into charcoal and really sequester that carbon. So if all you care about is CO2 emissions, that's a great way we can work with you, is carbonize any waste and really keep the carbon and not make fuels. Because yeah, the waste management company says if you're making fuels, then at the end of the day, you're releasing CO2 again. But if you make carbon, we just keep the carbon for a long time. We can put that into our landfills, they're saying. So yeah, very difficult to recycle plastics, what we excel at. And PVC, one of the most difficult to recycle. Even with pyrolysis, companies are struggling because it releases that chlorine gas, which is very aggressive and attacks your equipment as well. It can break down the metal in your reactor. And we have managed to really break this down into keeping it in salts so we can reuse it again, for example, to make PVC or any other chlorine-based products, with one of the largest cable manufacturers in the world. Another thing that might be relevant to you is rubber. We see this everywhere on ships as well. And this is very different compared to all the other slides you've seen. Here we're getting very high value gases like methane, propane, butane, but also ethylene, one of the key components in the chemical industry you can make from rubber. I mentioned earlier the first scale demo plant we're building. This is something we want to do in Europe, hopefully somewhere in a port where there's a lot of waste. Here, the driver really is the hydrogen. Hydrogen being the main goal of PLN, which is the largest energy company in the Southeast Asia. They want hydrogen for electricity, for fuel. Hydrogen is great if you can transport it. So we are not making this where the waste is, but we are building this plant right inside their complex, their chemical complex, so that the hydrogen does not need to be transported. So whenever you want to do hydrogen project, really think about the logistics first. And our recycling plant is very small scale compared to other like steam methane reforming to make hydrogen. This is much smaller scale. It's much easier to put this right into your complex, into your harbor. And of course, we also make other biochemicals at the site, for example, methanol. In this case, this is very low carbon footprint because it's made from only organic waste. So when we burn this, yes, I said earlier, methanol does have CO2 emissions, very low, but it does have CO2 emissions. But these can be accounted as net zero because the plants in the palm oil industry, they first take the CO2 out of the atmosphere and then we burn this later. So it's a net zero cycle. So this is, if you want to reduce your methanol, your fuel CO2 emissions as much as possible, then please be in touch. And actually, as we are building this right now, the reactor has been completed and now it's being constructed this year. In a few months, we might have some samples. So if you're interested in getting a hand on one of these samples of methanol, it's not so difficult to transport. We can arrange that and you can have a look in your laboratory at the methanol, or you can run some tests on that. So we are very excited to extend this success we're having in Indonesia. Even it's quite far away from Europe. I realize that, but we can build the same thing anywhere in the world. We're really a global startup from day one with the chemical industry. Yeah, most chemical companies have bases in many different countries. And
About 5 more minutes if you would.
5 more minutes, great, thank you. Yeah, and with chemical with the chemistry, we also want to think about where does it make most sense to deploy this, especially when we're talking about hydrogen, very difficult to transport, but also other fuels. We can make this locally with Plastilist. Briefly, I talked about different gases. So depending on what we put into our recycling facility, we get different gases, but we can also very much control this method. So a lot of the customers, they want syngas, they want hydrogen, H2, and they want carbon monoxide mixed. And that is because this is the precursor to making a lot of the fuels. For example, synthetic gasoline and diesel from the aviation industry is actually the biggest push towards sustainable aviation fuel. We can make that from this syngas as well. So we can control with the chemistry and with the catalyst the ratio of the gases we're getting. Of course, there's some ways that produce more hydrogen, some ways produce more methane. But with the carbon monoxide, it's very much something we can control. So this is what we get out. And then the question is, what fuel do you want? Because it's really up to the long-term strategy of each company. Do you want to work with hydrogen or DMT? I briefly mentioned that. Or do you just want synthetic gasoline? So we can even make synthetic gasoline and diesel or biodiesel using Fischer-Tropsch process. And these are processes that are already there. They've been invented a long time ago, and there are already companies who've done this and scaled this. But more and more, actually, we talk to companies who are now building Fischer-Tropsch facilities in Europe to turn syngas into these diesel fuels. So if you're interested, please get in touch if you're interested in these fuels. So from syngas, we have different methods, but this similar is the case for methane. Methane, we can also get that from waste, but methane you can also get from cow manure, you can get that from biological methods like anaerobic digestion. And of course, it's also a main ingredient in LNG. And so methane has the advantage you don't have to actually process that, but you can use it directly as a fuel. But more and more, we want to transform this into low carbon fuels. For example, hydrogen. We want to maybe turn this into methanol. Why? Because it's easier to store, as I said earlier, or DMT. But also there are ways to turn this gas into liquid, similar to Fischer-Tropsch, where we, very similar, like on the previous slide, we're making synthetic fuels that you can just drop into or even blend with your diesel in your engine, so that you have this smooth transitions and you can really achieve your goals, your annual goals. Let's say your annual goal is every year 5% less emissions from your fuels. You can just drop in and you can very much calculate the cost of this because you can substitute the fuels. And that's a great way to make some progress and to really step-by-step transition to a low emission shipping industry. Okay, so this is our team. As I said earlier, we have more and more chemists in our laboratory. And if you're looking for a job in this field, also feel free to scan the QR code. We're always looking for the most talented people passionate about reducing emissions, but also waste. And more the oceans and the plastic in the oceans, the environment is really what's driving us forward. And I have a lot more slides depending on what people are interested. And these are, for example, some of our competitors that are mainly making very, very specific plastics, or I mentioned earlier gasification. And this is really why Plastilist, especially for mixed waste, if you have any specific waste, you can make, for example, an enzyme that is very good at doing that. But with any specific waste, the question is, how much do you have of that? Is it even worth spending hundreds of millions of scaling this up? Or should we be using plastless where we can make low-cost fuels? We can use those locally. We don't need to make plastics again, because in Europe we don't make so much plastics. Maybe we just want to make fuels and with that decarbonize the maritime industry. Just some questions, just some thoughts for you if you have more time in the open discussion later. I hope you can see the slides either in the recording or Sonia will send it to you, maybe the slide deck.
Yes, Robert.
It's just to complete
will.
here all the ways we've done. If there's anything we haven't talked about yet. We are, as I said, raising next year. We're raising Series A. We're always looking for partners to build these plants, and really it's a change. It's really a pivotal change in the world we're seeing right now, that now it's becoming possible to break all this waste down very successfully, and we can make a lot of money together. So please be in touch.
Thank you, Robert, very, very much. We can